All right, I think we're going to finally finish this R1 section today. We'll probably have a quiz on it next week, probably early next week. So maybe on Monday we'll do a little review, and then we'll have, maybe Tuesday, we'll take a quiz on this stuff, all right? So that's the plan, is have a quiz on each one of these sections. And I don't know how many sections it has. You could probably look it up. It's like 5 or 6 sections for this review section. So maybe halfway through, maybe after review 3, maybe 2. I don't know. Depends on how long review 2 goes. We'll have a test. All right. So I'm not going to wait until we get to the end of the review to have a test. So, what's that? No, it's like I said, there's like 5 or 6 of them. Yes. There's R1, R2, R3, R4, R5, R6. I think it's 6. I know there's at least 5. You can look it up. But anyway, that's what we're going to do. So we will have a quiz next week, early next week, on the stuff that we've done with the review 1. All right? And we'll see how that goes. Let's see. We did distributive property was the last thing. Let's talk about this word identity. Jot this down. Identity, properties. I'm not going to spend a whole lot of time on this. It's pretty basic. Basically, it's what do you do to a variable, right, or a number to keep it the same? So if I was going to add something together, what would I add to a number to keep it exactly that number it was to begin with? So if I had a 5, what would I add to this in order to keep it what it was, which is a 5? Yeah, 0. That's what the identity property is. So usually they start with a letter. So a plus 0 equals what? A. So that's the identity property for addition. What's the identity property for multiplication? So again, if I start with a 5 and I want to keep it the same, but I want to multiply it by a number to keep it a 5, what am I multiplying it by? A 1. That's right. So what do you think this is? A times 1 equals A. That's all they're showing you. Okay, what do you do to a number? What do you add to a number to keep it the same? You add 0. What do you multiply a number by to keep it the same? You multiply it by a 1. All right, that's that. Then we got this other word called additive inverse. It's just a fancy way of saying you're going to subtract something. So if I had 3, I would just do this. If I add it to a negative 3, what do I get? What's 3 plus negative 3? It's 0, right? And that's all this says. So I'm going to put it in letters. A plus negative A is 0. So anytime you take a number and you add its opposite number to it, right? So 3 and negative 3 are opposite numbers, agreed? If I add those together, I'll always get a 0. All right? So if I gave you the number 6 and I said, find the additive inverse. What's the additive inverse of 6? It's negative 6. That's the number. If I added it to it, I would get 0. What's the additive inverse of negative 8? It's just 8. So it's just a fancy way of saying, additive inverse is just a fancy way of saying it's the opposite sign of that particular number. Does that make sense? But it's just a little bit more wordy. Makes you sound smarter, I guess. I don't know what the purpose of knowing that word is, but that's what they want you to do. Now, that was additive inverse. I love this word. I don't know why. Multiplicative. How's that for a word? It just rolls off the tongue, doesn't it? Multiplicative. I don't know why I like that word so much, but I think it sounds cool. So now we're going to do the multiplicative inverse. All right. So what do we multiply a number by in order to get not a 0, but a 1? So if I take, 7, what am I going to multiply that by in order for that to equal a 1? Would it be a negative 7? Negative 7? 7 times negative 7 is 1? You sure you want to keep that answer? Can't? Negative 14. So negative 14 times 7 is 1? Don't think so. I don't know. 0? 7 times 0 is 1?
There isn't an answer. You have to divide it.
Let's say you didn't know what the answer was. What could we put in for this? If I don't know what it is, yeah, let's put in an x. Let's figure out what it is. So 7 times x, right? How do I get the x by itself? How do I solve for x?
Wait, is it
Divide by what?
1 over 7.
Thank you. It's 1 over 7. So you divide by 7. So what is the multiplicative inverse of 7? I'll put an arrow. They're not equal to each other, so I'm not putting equals, okay? But what is the multiplicative inverse of 7? It's 1 over 7. What's the multiplicative inverse of negative 3? Is it 1/3? It's negative 1/3, right? The sign stays the same, right? I didn't change the sign here, so I'm not going to change the sign here, all right? What about this? What about 3/4? What do you think the multiplicative inverse of 3/4 is? Again, 3/4 times what is going to give you 1? It is 4/3. Very good. Okay? Because if I want to get x by itself, how do I get rid of this? Well, it's not cross multiply, but you multiply by the inverse. Okay? It's the multiplicative inverse. So you multiplied this by 4 over 1. I'm sorry, 4 over 3, not 4 over 1. And look what happens. They cancel, so x is what? 4/3. So what's the multiplicative inverse of 3/4 without doing all that math?
Just you flip it.
Yeah, just flip it. That's exactly right. We just flipped this, didn't we? Because that was 7 over 1, wasn't it? All right, so we flipped to get 1 over 7. This was negative 3 over 1, so we flipped it to get negative 1 over 3. So how do you find the multiplicative inverse of a number? You flip it. Or you take, here's a better math word than just flipping it. We have a math word. Just one word. Instead of saying multiplicative inverse, even though that's fun to say, there's one fairly easy word that we use, and we use it a lot in math. Starts with an R. What does it mean to flip a fraction? Starts with an R. I know you've heard this word 100,000 times. What is it? No. Thank you. It's reciprocal. You've heard that word before, haven't you? Yeah. Absolutely. All right. We don't have to have a conversation every time I say something. Let's pay attention. So it's the reciprocal. It's the reciprocal. What does that mean, reciprocal? Flip the fraction. That's all it means, okay? But it's a fancy math word that means you just take a fraction and you flip it. So what's the reciprocal of 2/3? 3 over 2. What's the reciprocal of A over B? It's B over A. Everybody see it? All right, that's reciprocal. Another word for it means the same exact thing. It's just a little fancier. Multiplicative inverse means reciprocal. And we're going to be talking about that every once in a while, the word reciprocal. So that's pretty fun stuff, isn't it? Let's do a couple more words, and then we'll do some examples. Then we'll do some math. Haven't really done much math just yet, but we will. What does it mean? We might have even talked about this earlier, but this is in my notes, so I'm going to go through it. What if I say the difference between two numbers? What does that mean I do to those two numbers? I subtract the two numbers. That's right. So if I have A and B are my two numbers, what would the difference be? A what? Minus B. All right? All right, everybody with that? What does it mean to find the quotient? It is. It's division. So how would I write it with A's and B's? If I said the quotient of A and B, what was that? It's A over B. A divided by B. We good? What if I multiply by 0. Honestly, you're right. So if you multiply by 0, any number at all, let's take a 5, and I multiply that by 0, what are you going to get? 0. What if I take a negative? What if I take a negative 3/7 and I multiply it by a 0? What am I going to get? I'm going to get 0. Anytime I multiply by a 0, my answer is always what? What if I take A, could represent any number, and multiply it by a 0, what am I going to get? I'm going to get 0. It doesn't matter what it is. If it's negative, positive, it's a fraction, it's a decimal, it doesn't matter. There's a lot going on, and I don't appreciate it. I'm trying to teach. We don't have to make a joke every single time I say something. So let's just be students. Let's sit. You can participate. If I ask you an answer to a question, feel free to just say it out. You don't have to raise your hand or anything. Okay, but there's too much going on. Every time I take a breath, somebody's got to say something. All right, let's be good students and pay attention to what I have to say. There's too few of you in here for me to be saying that. All right, let's talk about, and it seems like we've talked about this, but this is where it is in the notes and in the book, so we're going to do it again. But I think it's good to do this again. All right. If you're going to multiply, maybe we did this with addition. Maybe we didn't do it with multiplication. But with multiplication, okay, if I multiply two numbers together and they have the same sign, what do I mean by the sign, by the way? Positive and negative, right. So the signs are either positive or negative, okay? What's the only number that exists that isn't either positive nor negative? That's 0, right. But all the other numbers, whether they're decimals, fractions, whole numbers, or integers, they're either positive or negative. So if I multiply two numbers with the same sign, that means positive times positive. That means... All right.
Thank you.
So if I have a positive times a positive, what's that always going to give me? It's going to give me a positive. Okay? So when I have two of the same signs, if I have two of the same signs, your answer is always, watch, your answer is always positive. You just have to remember this rule. After a while, it'll be so second nature to you, you won't even have to think about it. But if I have a positive times a positive, it's going to be positive. They're the same signs, right? They're both positive. What's your other possibility to have same signs? They're both what? Negative. If they're both negative and I multiply them together, what's your answer going to be? It's going to be a positive number, all right? Anytime that you have the same signs, your answer is always positive. You got it? So let's do a couple examples. What if I had negative 3 times negative 3? That's positive 9. A positive 9. Why? Because they're the same signs. What if I had a positive 2 times a positive 2? That's a positive 4. We know that. We've been doing that since we were little kids, right? Both positives. But when you have the same signs, your answer is always, always, see that? Always, double underline, positive. What if you have two different signs? Two different signs. Remember, this is multiplication. Actually, to tell you the truth, it's multiplication and division. So this works with multiplication and it works with division. All right, it's the same rules. So I have two different signs, which would be what? One's positive, one's what? One's negative. Oh my word, what's going on today? So if I have a positive and a negative, they're different signs, and I multiply them together or I divide them, what's my answer, what's the sign of my answer always going to be? It's going to be negative. It doesn't matter if the positive is bigger, smaller, first, second, doesn't matter. If I got one positive and one negative and I'm multiplying together, or if I divide them, I'm always going to get a negative answer. Okay, so you could put the negative first and the positive second. Does that make any difference? Not at all. You'll always get a negative answer. So let's do a couple problems. Negative 3 times positive 5. That's negative 15 because I got two different signs. Let's do it the other. Let's go negative 5 times, well, let's go the other way. No. Let's go positive 3 times negative 5. Doesn't matter which one's negative, which one's positive. It does not matter. As long as you got one positive and one negative, my answer is always going to be negative 15. And, well, in this case, it's going to be negative. It's always going to be negative. All right, enough of that. Everybody good? All right, we're rolling right along. Let's see what I want to do now. All right, let's talk about this thing. They call this the cancellation property. All these properties. Cancellation. You've done this lots of times in your math career up to this point. Cancellation property. What if you had like 3 over 3? That's division, isn't it? 3 divided by 3. What's anything divided by itself?
1.
It's a 1. So what we could do, we could say this, and it's fine. Math teachers say this all the time. We could say that 3 goes into 3 once and 3 goes into this 3 once. So we could just do what to them? Cancel them out. Now, they don't just cancel out and just vanish into thin air. They become what? It becomes a 1 up here and a 1 up here. 1 divided by 1 is 1. So that's the cancellation property. For instance, if I had AC over BC, you got the same number that's being multiplied. Notice, it's being multiplied. This does not work if they're being added. If this was A plus C, you can't cancel them out. Everybody hear me? That's super important. Out of anything I've said today, that might be the most important thing I said today. All right, you can only cancel them out if the same number on top and bottom are being what? Multiplied by something else. All right, C is being multiplied by A. This C down here is being multiplied by B. Yes, you can cancel them out. So, bang, bang, canceled them out. All right, and then what am I left with? A over B. All right, that's when you can cancel stuff out. Now look, don't even write this next part down because I don't even want you to, I almost hate to even show it to you, but I will. Don't write this down. A plus C, B plus C. Do the C's cancel out here? What did I just say like 15 seconds ago? Why not? Right, you can't do it when they're adding. You can only do it when they're being what? Multiplied. Okay, only when they're being multiplied. You cannot cancel out when they're being added together like this, okay? Why do you cancel here? Because multiplication and division are inverses of each other, right? They're opposite operations. Addition and subtraction are opposite operations. Is addition and division opposite operations? No, so they don't cancel out. You got it? Do I need to say it anymore? I'll say it again. When this is being added and this is being added and you got one on top of the other, they do not cancel out. So you can't do anything with that. Okay, you can only cancel them out when they're being multiplied. Got it? Okay, that's super, super important. Here's another one, another property. Well, let's do this first. Let's do a couple examples with that cancellation thing before we move on. Here's an example. It's example 19. It's got 2 parts. You've seen this a whole bunch in your math career, right? Haven't you seen stuff like that? Sure. So what do? We got to get x by itself. How do we get x by itself? Get rid of what's being multiplied. What's the opposite of multiply? Divide. So we divide by 2, right? Because I want to get rid of that 2. Come over here, get rid of the 2 here. Now, this is where that cancellation property comes in handy. Because what can I do with that 2 and that 2 right there? Yeah, divide or cancel them out. That's right. They cancel out to be a 1. 1 times x is just x. what can you do here? You can do a little canceling here, but you can't just go bang, bang, and they go away to nothing, all right? What divides evenly into both of those numbers? 2 does. So 2 goes into, right? We say goes into, but divides into 2 how many times? Once. 2 divides into 6 how many times? 3. So what's x equal to? 3, because it's 3 over 1, all right? So you've done this cancellation property many, many, many times. Let's do another one. What if I had this? What if I asked you to simplify or reduce? A lot of times they'll say reduce the fraction. You've heard that before, right? Reduce the fraction. What do we do here? Well, we try to find a number that divides evenly into both of them. Like right here, 2 divided into 2 once, 2 divided into 6 3 times. What number divides into both of these? What's the largest number? Okay, a 6. Now a 2 goes into it, right? But then you're going to find out you're going to have to divide again by something, all right? But if you just realize there's a 6 that divides evenly into both of these. 6 divides into 12 how many times? 2. 6 divides into 18, which means what? When I say 6 divides into 18, it's 18 divided by 6, right? What's 18 divided by 6? It's 3. So that cancels out, becomes a 3. And what are we left with? 3 over 2. So that's how we can use that cancellation property in a couple different ways. There'll be a lot of times where you have to cancel stuff out. We did a thing the other day. Remember we did that little factor tree thing? All right. You could do that here, but this was kind of easy to see how to cancel that stuff out. All right, enough of that. Let's do this. Now, I know we've already done this, but we're going to go through it again. This is where they officially taught it to you. They call this the arithmetic. When do we get out of here? Is it 12:15? Yeah. Okay. So the arithmetic quotients. All right, we got 3 of them. So watch this. Quotient means divide, correct? So we're going to have some division. In this case, they're fractions. C over D. Now, how do we add fractions? We've talked about this before. Okay, you actually done some problems already on this because I kind of gave you the problems without teaching the thing. But you probably already know how to do this. What's the key thing when you're going to add fractions together? To find a common denominator, okay? So we're going to find a common denominator here. Watch, I'm going to put this plus this. So what number does B and D divide into evenly? What's the easiest way to figure out what they both divide into? Just multiply them together, all right? If I multiply the B and the D together, that's your common denominator. Everybody see that? Aiden, you get this? Look up here. You're not getting this. Okay, B and D. So I multiply those 2 together. That's my common denominator. That always works. Like if I had like x over 2 plus x over 3, what would your common denominator be? What would you do with those 2 numbers? Multiply them together. So your common denominator would be a 6. Would you agree? What if you had weird numbers that, I don't know, let's say x over 273. We're not going to actually do this problem. It would be a mess. And if I had 507 or something weird like that, all right? How would you find a common denominator with both of those? It's not necessarily the smallest or the least common multiple, but how would you find the common denominator or a common denominator? What'd you do to these? What'd you do to the other thing I had that I just erased? What is it? Just multiply them together. That's right. Now that'd be some ugly, weird number, wouldn't it? But that's how you could find a common denominator. You can always just multiply the denominators together. Sometimes that's not the best way to do it, right? But it's always a way to find a common denominator. Make sense? So that's why we're doing this here. Now, here's the key. how do I find the numerators? I'm not just going to put an A and a C right there. That's not the same thing. But what did I do to that B in order to get BD? I multiplied it by a D, didn't I? So I'm also going to have to do what? Multiply the top by the D. Everybody see that? What did I do to that D to get BD? Multiply this by what? A B. So what do I do to the top? Multiply that by a B. So what are we left with? I got AD plus BC. And that is how you would add those together. That's probably the one thing about fractions that most people hate, okay, is adding or subtracting fractions. The same thing works when this is a subtraction, all right? Same exact thing. But when you multiply fractions, that's usually a little easier. So what if I had AB, or A over B, sorry, times C over D? This time I don't have to find a common denominator. I can just multiply straight across the top, straight across the bottom. All right? It's as easy as that. Now there might be some times where you can cancel stuff out, but in this situation, they're not regular numbers, they're variables. So really, only thing I can do here is just multiply straight across. So what is it if I multiply straight across? A what? AC over what? BD. Good. So that was kind of easy, wasn't it? Just multiplying straight across. Yeah, the common denominator thing absolutely is the hardest out of all of these, but that's how you do it. Okay, one more thing, number 3. Now we're going to take these fractions and put it into one big fraction. So we're going to have a fraction divided by another fraction. So I'm going to put A over B. Instead of times C over D, what am I going to do? Divide it by, and I show division by a fraction. So it's two fractions in one big fraction is what it is. So it's A over B divided by C over D. Everybody with me? Do you remember what division is? If you're going to divide numbers, dividing is the same thing as multiplying by the reciprocal. You remember that word. Just a few minutes ago we were talking about that word. So division is the same thing as multiplying, but not just multiplying by the reciprocal. What does that mean to do the reciprocal, especially for a fraction? You flip it, okay? So let's do this. So what we're going to do is we're going to take the top divided by the bottom. Everybody see it? So you keep the top exactly the same. So what would the top be? A over B. Instead of dividing, what is division? Multiplying by the reciprocal. So I'm going to go multiply by the reciprocal of this one. What's the reciprocal of C over D? Very good. D over C. That's the reciprocal. And now I can multiply those through. Now I can do the multiplication. What is it? AD over BC. All right. Make sense? Yeah. All right. All that to get to a couple examples. I got 5 minutes to do 3 examples. I don't know if I'll get all of them done, but I don't have to do every single one of these. Actually, this example has 4 parts to it. I'm just going to do the hardest one, and then we'll go to something else after that. So this is example 21. If you want to go in the book and look, they'll do a few more. So it's 2/3 plus 5/2, 5 over 2. Remember, this is the one that's the hardest out of all of them. But we got to find a common denominator. So I set up 2 fractions, just like I had here, but I'm going to have a different denominator, and I'm going to have a different numerator too. How do I find the common denominator? If the numbers are super easy like this, how do I find any common denominator? Just do what? Multiply them together. So 3 times 2 is 6. That's my common denominator. And this is 6 as well. Because I know that 2 divides into this evenly, and I know 3 divides into this evenly. But, remember I did this in red? We'll do it in red again. What did I multiply the 3 by to get 6? 3 times what is 6? 3 times 2. So what do I do to the top? Multiply the top by 2. Let's do this bottom. 2 times what is 6? 2 times 3 is 6. So we do the same thing to the top. 5 times 3. We good? So now let's do this. I already got the 6 here. 3 times 2 is 6. What do I got on the top? 2 times 2 is 4. Isn't that the same as 2/3? Yeah. What do I do here? I already did the 2 times 3 is 6. What do I do here? 5 times 3 is 15. Now, here's how we write the answer. We keep it over the common denominator. Do not go 6 plus 6 is 12. That's not what we do. Okay, we keep the denominator the same. So we're just going to put it over one denominator. Do not go 6 plus 6. But now what can we do to the top? The top, we go 4 plus 15, which is 19, and that's our answer for that fraction. So you got to know how to do stuff like that. Example 22 is the least common multiple. We kind of did this the other day, but this one's a little bit of an easier number, so let's do it one more time. It wouldn't hurt doing it one more time. So what if I asked you to find the least common multiple? Remember least common multiple, LCM?
Yes.
What do we do with these two numbers? Let's break them down. Do the tree. Break them down into the smallest factors, okay? So what times what is 15? 3 times 5. Okay, what times what is 12? 4 times 3. Now we can break 4 down, right? So let's break 4 down. What's that? 2 times 2. Keep that right there, and that's a 3. Everybody see that? So I've got 3 and a 5 over here, and I've got a 2 and a 2 and a 3 over there. Now, what do I do to find the least common multiple? I find which numbers show up in either one or in both of them. They don't have to be in both of them. They can just show up somewhere in either one. So what's the smallest number I'm dealing with here? The 2's, all right? There's 2's here. Now, there's not any 2's here, but does that matter? No, they don't have to be in both spots, all right? But how many 2's do I have in this spot? I got 2 of them, so I'm going to write both of them down. 2 times 2. Everybody with me? What else do we have? What's the next biggest number? 3. I got 1 3 here and 1 3 here. So it only shows up one time in both places, right? So I only got to pick one of them. All right? So don't pick them both because there's a 3 here and a 3 here. If they're in both places, you just pick the one that shows up the most number of times. If it's the same number of times, once here, you just pick one of them. So it's times 3. See that? So I'm picking that and I'm picking that. What other number shows up? A 5. It doesn't have to be in both spots, but there's only one 5 here, so I'm going to pick that. Now what am I going to do to those numbers? Multiply them together. That's right. So 2 times 2 is 4, times 3 is 12, times 5 is 60. That is the smallest number that 15 and 12 divide into evenly. So if I had a fraction, if I had like 7 over 15 plus 2 over 12, let's not use a 2. Let's use a 5. Okay? What if I had this? I need to find a common denominator. Instead of just going 15 times 12, I find the least common multiple. What would it be? It'd be 60. So I put a 60 here, put a 60 here. And then I say 15 times what is 60? I think that's 4, isn't it? So that's times 4, so I multiply that by 4. 12 times what is 60? 12 times 5 is 60, so I multiply the top and the bottom, and that's a 25. I'm going to add those up, 40, 53, right? 53 over 60. That's how I would do it, okay? You guys with me? I've actually already given you homework over this stuff. So I think what I'm going to do on Monday, I was going to have this for you today. I'm going to give you a worksheet with a bunch of fractions on it. I just didn't have time to do it today. So I'll give it to you on Monday. No homework this weekend, okay?
Yay.
So no homework.